All right, good morning. Welcome back to Math Today. We are continuing on learning about equations and multi-step problems, which I know is not very easy, but we're challenging our brains. So, today we are on page 100 and 101. This little problem here sets us up for the whole rest of the page. So everybody, we need to pay close attention as we read our problem. Do I have a reader? Liam?
Garrett is paid $4 for every hour he babysits. Mrs. Becker paid him for 5 hours of babysitting. On the way home, Garrett spent $9 on a book and $6 on a puzzle. How much money did Garrett have left from the money he received from Mrs. Becker?
Okay, so how is this different from the problem we did yesterday? Emma?
I forgot.
You forget? Anyone have an idea? Josiah?
Instead of trying to figure out how much money they spent, you're trying to figure out how much money you have left.
Okay, we have to first figure out how much he got paid. Then he went and spent some of his money, and we need to know how much he has left. All right, so let's mark up our problem. First important thing, he gets $4 for every hour he babysits. So $4 an hour, mark it up. Mrs. Becker paid him for 5 hours. And then on the way home, he spent $9 on a book and $6 on a puzzle. And our question is, how much money does Garrett have left from the money he received from Mrs. Becker? So definitely multiple steps. And we could probably do it without writing an equation, but we're practicing equations. All right. Okay. So we've marked up our problem. We know what's important. So if you were going to solve this on your own, that is step one. Okay? All right. Now they did another model. You know how I feel about the models. They don't help me a lot, but let's go over them. What do these $4 chunks mean? We've got 5 of them. So think about our problem. What do they mean? Abby?
For every hour that he babysits.
You got $4, right? So this row is showing us 5 hours of babysitting. So I would go ahead and write that down. If I'm writing it, it's probably important to write down. What's the bottom row showing us? It's different. Noah?
How much he spent on games.
Okay, so this shows his spending for these two parts. And then this part will tell us what he has left. Okay, we can also use the bar model to write equations for the problem. So if we let B equal the amount of money Mrs. Becker paid Garrett, I would recommend rewrite it again. It helps you stay involved if you're writing. So if B is the amount of money he makes while babysitting, how do we know it's 5 times 4? Hayden?
Because it has 4 and 5, so it counts 5 in each. Well, you can count all the boxes on top,
Uh-huh.
and then you can you got 5, so and then you see the numbers.
Okay. So if we connect it back to the problem, though, Josiah, what do those numbers
There's
represent?
5 groups of 4, so you're going to need to multiply them to figure out what the answer is.
All right, we got 5 groups of $4. He worked for 5 hours, got $4 an hour. And now, if he spent $9 on the book, $6 on the puzzle, so the amount he spent was 9 plus 6. So, I'm going to rewrite this larger. So everyone write it with me. L is the amount of money he has left over, which is what we want to solve for. So first they're saying we can put a B in here. What did B stand for? Abby?
How he has to babysit.
How much money he earned while babysitting, right? Okay, so B is how much money he earned while babysitting, and then we're going to take away the amount of money he spent. So I know we have 2 different variables now, but we can solve for B and fill in for B. I just want you to rewrite it, think about that. Hayden?
B is 20.
B is 20. So if we filled in B is 20, we could solve the parentheses and finish our equation. Okay, so before we get ahead of ourselves, let's go to the top of the next page, page 101. Look at the second modelet. What is represented by times 4 in the equation 5 times 4? We just talked about it. Someone review it with us. What is represented by the times 4? Might have to call a victim. Liam?
How much money he got paid for babysitting?
Yeah, the 4 is how much he was paid per hour. So I'm going to say 4 equals how much money each hour. It's the shortest way to say that. Everyone should be writing that with me. All right, I'll be back. All right, we are back again. So number 3. Why are the two amounts that Garrett spent in parentheses in the equation, 9 plus 6, why is that in parentheses? Noah?
Because he bought 2 things that were 9 and 6.
Uh-huh.
And we have to add those together to minus what we get on B.
Okay, so we have to add them first. So if we put them in parentheses, that means add them first. All right, why are the two amounts parentheses? We need to add both items he bought. Just making sure we're all writing this with me. This is what we're doing in math class, pencils in hand. We need to add both items he bought first. And parentheses tell us to do things first. Hayden.
I said parentheses equals do it first and add 9 and 6.
Sounds
before
good.
anything else.
Yep, you can always use your own words. Give me about 10 more seconds and we are moving on to number 4. Okay, so Alyssa combined the two equations into one equation, which is the one we had down here on the bottom. L equals 20 minus 9 plus 6. Now we already talked about this a little bit, but what does the 20 in that equation represent? And if you're forgetting, look back over here. Remember we have a B that stands for the amount that Mrs. Becker paid Garrett. So what does the 20 in this equation represent? Abby?
How much money he earned every month.
Exactly. So the 20, just like over here, B is the amount she paid Garrett. So 20 is the amount of money he earned. So instead of leaving it a B, like we had over here, she went ahead and filled it in. She knew that 5 times 4 would be 20. Okay, now I want to go ahead and solve this equation because we haven't even solved it yet. So we probably have some room on this page. So I'm going to go ahead and write it in. We've got L equals 20 minus parentheses 9 plus 6. You should always be writing this. So L equals 20 minus 9 plus 6, the equation that we just talked about from problem 4. Now let's solve it. We practiced solving equations yesterday. So first step, I've got to copy everything down and I've got to do the parenthesis part first. So in my parentheses, I've got 9 plus 6, which would be what? Cadence? 15. Now I can solve for L. We know 20 minus 15 is what? Josiah?
5.
5. So if we return to our problem to remember what our label should be, how much money did he have left over? $5. Okay, so he's got $5 left after buying all the stuff. All right. Now this guy, Ben, he used a different equation. His equation, let me write it larger. You don't have to write this, just so people at home can see it. L equals 4 times 5 minus 9 minus 6. Now they want to know if that equation's going to work. So I want everyone to look at it. You have to use your eyes to look at it, either in your book or up here. Would Ben's equation work? James, what do you think?
Yes, because B equals 5. You get 20 and minus 5.
Okay. Hayden, you think the same thing? Yeah, so sometimes can we use a different type of equation to solve the same problem? We absolutely can. So when I've told you that math can actually be very creative, it can be. The older you get, when you write your own equations, you can come up with it the way you like it. So this is a different equation. We'll get the same answer. So let's go ahead and solve it together. Cadence walked us through it. So 4 times 5, we already know that's 20. Well, and then we subtract 9, and then we subtract 6. So 20 minus 9 would be what? Abby?
11.
11. And then we take away 6 more from 11 would be, Cadence? 5. So this whole thing, L equals 5, we can say, yes, it works. I am out of room to explain, so I will let us have an explanation discussion instead of writing. So someone explain it out loud. I'll have 2 people explain in their own words. Noah?
I had one thing. What if the 6 minus the 9 and the 9 was minus the 20? Or the whatever you would get from the minus the 6 on the minus the 9?
Repeat that for me.
Wouldn't the 6, you would minus that from the 9 and then do it with the 20? So it wouldn't work, technically?
You always do parentheses first.
Yes.
So if you always do parentheses first, we'd have 20 minus 9, which I know is 11, minus 6 would be 5. So it does work.
Oh.
All right, Abby, explain it in your own words.
It works because if you do 20 minus 9, that would be 11, and 11 minus 6 is 5.
Okay. Makes perfect sense. All right, 6. Explain how it's possible for 2 equations to look different but still show the same problem. That's kind of what we've been explaining. I won't make you write this one either. If Josiah, you want to explain it for us?
So basically, is basically the same question, but just bigger.
Yeah. Can we think about math in different ways? Yeah, the same as we can with reading, with everything. So sometimes we think math is always this way, this way, this way. Well, actually, the older you get, you'll find that math is kind of creative. And I like writing equations. The older you get, you'll probably get into it as well. Okay? All right, I am going to scroll up a little bit and make this problem larger. So we are going to do the bottom problem. If you need your whiteboard, because I realize there's not much space, go ahead and grab that. All right, friends at home, same to you. There's not much space here, so you can grab paper or whiteboard to solve our last problem, number 7. Okay. Everybody ready? Okay. So, using what we just learned, we are going to solve number 7. First thing we've got to do is mark up our problem. Pencils in your hand, ready to go. Let's mark up our problem. There were 4 vans and 2 cars going to a museum. That's probably going to be important. Each van carried 9 people. Big van. Each car carried 3 people. Small car. Now, we need to write an equation to represent the number of people who traveled in a van, which is going to be V. V will stand for van. Then write an equation to represent the total number of people who went to the museum, which will be T. Okay, so we have multiple steps to do here, so stay with me the whole time. All right. So I'm going to write my info over here because I like to see it visually. We have 4 vans.
Yeah, I wrote.
And we have 2 cars. Now, 4 vans, how many people will fit in each van? Abby?
3.
Whoop, van.
9.
9, big van. Okay. So, I have 9 per van.
Where'd you get 9?
Right here. Each van carries 9 people. All right, now when we think about our cars, how many people fit in each car? Emma?
3.
3, small car. 3 per car. So first thing they want us to do is write an equation to represent the number of people who traveled in a van, which is V. So V equals, how do I find the total number of people that traveled in a van? We know we have 4 vans, and there are 9 people in each. Liam?
9 times 4.
9 times 4. So V equals 9 times 4. We answered the first step. Okay, that was this one. Write an equation to represent the number of people who traveled in a van. We did it. Second step. Then, write an equation to represent the total number of people who went to the museum, which we're going to say equals letter T. So, make a big T. That's the total number of people. Well, can we start with this?
Yeah.
Okay, so we can say, can we say V instead of 9 times 4? It's kind of adding us another layer. Do these things mean the same thing? Yeah, there's an equal sign. If you have an equal sign, remember both sides are exactly the same. So we can go ahead and put a V. So we've got the van people. Who are we not including yet? Cadence? Car people. So are we going to add the car people on, subtract them, multiply them? What do you think? We need to add the car people on. Now how do I find out how many car people there are? Noah?
You would do 2 times 3.
2 times 3. I have 2 cars. There are 3 people per car. So we can do 2 times 3. Okay. So our last step, we need to figure out what V equals. We can fill in for V, then we can solve the whole problem for T. All right, Hayden, if we solve for V, what would V equal?
36.
36. Excellent. So we can fill in, we copy our equation. V is 36. So that's the total number of people in the vans. Plus, what is 2 times 3? Abby?
6.
6. All right, we got one more layer. Remember, rewriting your equation really helps everything not get messed up. The older you get, you'll need to do that. All right, 36 plus 6. You can either count on in your head, or you could stack it and add it. Noah?
It's 42.
42. All right, now what would my label need to be? If you forget, always go back into your problem and reread the question. Hayden?
People.
42 people.
That's a lot.
All right. Now I want you just to all sit back and kind of look at what you just did. Very proud of you all. This is hard stuff, so awesome job. You're doing now algebra problems with 2 variables. What? You should feel proud of yourselves.
Variables?
Yep. Remember, variables are the letters that represent things. Cadence?
Can I get paper and write them down?
You what?
Can I get paper and write them down?
All of this?
Yeah.
Sure. All right, any questions? Okay. All right, friends at home, you should be proud of yourselves and impressed as well. Thanks for working hard. See you later.